In the name of Almighty God, I'm Mahsa Sankasha, and today I want to talk about how to apply a force on the box. And as you see, there is a applying force here, and it's very simple. I want to show you in the Abaqus 2024. Firstly, there are some modules here: part, property, assembly, step interaction, load, mesh optimization, job visualization, and finally a sketch. The part module, I wanna go through the part and the sketch. You see that there is a sketch here. You can make a rectangle, circular, or elliptical, or other sort of shape here. After you made your shape, you successfully can go and make a extrusion for this shape, such as you have seen this part. So there is extrusion here, and this extrusion is solid and is specified for modeling as 3 dimensions. Then the next section, we wanna select this whole box as a one set. It depends on how many parts do you have. For example, if you have a geometry which is included different and various parts, you can have different sets and different surfaces in order to have a specific intention and plan for every single part. Then we want to go to the section assignment. In the section assignment, you can make sections and assign these sets to these sections. We will do it because of the this sort of solid and the material. Before we go through this section assignment, firstly we need to go to the material is a subsection in the property module. You go to the material and you can select from the general menu the density. Here is 4000 kilogram per cubic meter, and then you can select the elastic and Poisson ratio. Also the elastic is isotropic. You can also select anisotropic, traction, shear, and also other sort of types. There is a modulus. You can define the fail stress or fail strain, and also the Poisson ratio, which is the equation when the width and height is the equation width and height displacement. Then after defining the materials, we go through the section assignment and assign these sections, this set to this section and this section to this material. Then we go to the assembly parts, and we can create assembly and uh, bring this one to this assembly. So you can also select different parts. For example, if you have other sort of shapes, you can add here in order to make it as a mesh, because in Abaqus we are using finite element method and or FEM, and because of that we have to make this shape or this as instance as a independent. So here we have an independent sections, and you see that there is a mesh part, mesh module. So this mesh module we created, it's a rectangular and approximated global size is 1. Wherever we have a less a number, a less value here, we have a finer mesh, and so we consume more time to calculation, but also we have a high accuracy. Then you can select these sections as a mesh part instance. Finally, we go through the step. In a step, we assign the time. The initial time is well as default, And now for this applying force, I have used dynamic implicitly. You see that energy ohm is off and implementations. We have a maximum number of increments as a 100 increment size is initial 1 and minimum is 1 multiplied by 10 to the power of minus 5. So after that we can apply the load or interactions. So as you see, there is a boundary condition in the bottom of this box, and it is as an incaster, which means that I have fixed this part in order to apply any sort of strong load. And here you see that we have a three dimensions. Here y is these sections, and we wanna apply from the top to the bottom, so I have used the negative sign for this value. And you can also have amplitude by the sort of create amplitude as a tabular, or also you can have analogous actuator spectral and etc. As you see, we have a periodic modulated decay, solution dependent, smooth step, actuator spectrum, PSD definition, and so on. But I have used the instances here. After that, we go to the job, make a job and submit it, and we wait until the result in a visualization modules appear here. You can go to this palette contour on the form shape, and you can see that how it's this deformation is happening here. Also, there is a possibility to make a XY data. So again, I want to go to the results. You can go to this XY data and make some tabular from the history, which show you the parameters such as thickness and also stress strain. These sections have been assigned the step module, and as you see here we have a defined for field output manager. As you see here, we have a stress, strain, displacement, forces, reaction, contact, and you can select thermal if you load any sort of thermal failure fracture and etc. So if you select this one here for any sort of domain, for example, I have selected the whole domain, you can specifically select a set or part or substantiated from every single sections and study about the parametric that you have used here. Also, there's a history data here. You can also check it and change it accordingly based on your what you are searching for. Also, there is a possibility to apply the temperature. This temperature will be happen after you select the interaction here. You can make an interaction major. You can select the friction. You see have a we have a surface to surface contact. This surface to surface contact, you see that we can select this surface, and there is a finite sliding between the some surfaces, and there is a frictions that we can, and clearance, this free clearance and also friction make a thermal things, thermal parameters, and we can extract it from the uh, plots in the visualization modules. So thank you so much for watching my tutorial video until the end. Also, you can download it from my github.com/kashi script.